Teacher's Corner, we're going to look at graphing reciprocal functions. Now, when we're looking at a parent function of reciprocal function, it does take the shape of a hyperbola. There's the equation or the function. Now, we do have asymptotes, and what asymptotes are is they are lines that appear on the coordinate plane in which the graph gets really close to but doesn't touch. Okay, so in this case, we know that x can't be 0. So we know that my x value can't be 0. It can be anything but. It could be 0.0001 or negative 0.001. It just can't be 0. Okay, and we're going to have the same thing with our y value as well. It's going to be very close to that y is equal to 0, but it's not going to touch it. Now we can do some transformations. A hyperbola has two pieces, which are mirror images of each other, opposites of each other. Okay, so we have some translations here. Okay, so we know that k, whatever k is a vertical translation. It's going to go up or it's going to go down. This h value here is going to cause the graph to go left or right. Okay, and then we have some other things about a. If it's less than 0, then the graph is reflected across the x-axis, and it talks about how stretched out really that graph is going to be. So we're going to use some tables for that as well. All right, let's take a look at the first one. We're going to graph it. We're going to find the domain range and the asymptotes. And the domain and range are also going to help us with the asymptotes and vice versa. Okay, so first of all, actually, let's just write this at the top here. We know that our equation, f of x, such that a over x minus h plus k. Okay, so right now, this is really plus 0. We don't write it, but it's plus 0. And that's our horizontal asymptote. So we know that in this case, the asymptote is going to be y is equal to 0, that line. Now I know if I look at this, I know that x can't be equal to 3, right? Because 3 minus 3 equals 0. And we know that I can't have 0 on the bottom of a fraction as our denominator. So x is going to equal to 3. They're things that we can have. Now that helps us with domain and range. The domain is such that x can be any number except for 3, cannot be 3. Same thing with the range, f of x, such that f of x cannot be equal to 0. Okay, because that k value here is 0. Now, I'm going to draw my asymptotes because it'll help a little bit. So when I graph the y equals 0, right here along the x-axis, and we'll have arrows on the end, and the same thing with x is equal to 3. I know that my graph has to keep that in mind as well. Okay, now we are just going to pick some points and we'll kind of see how this hyperbola goes. So if I pick x is equal to 4, because I know it can't be on 3, I'm going to substitute it in and I get 2. Now I'm going to pick a couple values. If you want to pause the video and fill them out yourself, you're certainly welcome to do so. So if x is 7, then I have 1/2, and I have 2 and negative 2, and then I have 1 and negative 1. So you'll see I tried to pick a couple points that are on either side of the asymptote line so I can figure out where things are. So I have 4 and 2 is going to go here. And then I have 7 and 1/2, it's going to be here. So what's going to happen here is this graph is going to go this way, going to get really, really close, but never touch. Now I'm also going to have a mirror image, so I know the other side should be right there. So that's why I picked a couple values to the left of this vertical line here. So I have 2 and negative 2 is here, and then 1 and negative 1 is here. So again, I know that that hyperbola is going to kind of hug the asymptotes but not touch it. And that's what our graph looks like. Okay, let's look at another one. Again, slightly different because we have this 2 here. So I know that my asymptote is going to be y is equal to 2, and also because of my denominator, I know x is equal to 4. So they are lines that the graph is going to approach, but it's not going to touch. So I have y is equal to 2. So we're going to have this here. And I have x is equal to 4, which is this here. And again, because of our domain, we're going to have for our domain, we are going to have x such that x is not equal to 4. And our y will be f of x such that f of x is not equal to 2. Okay? All right, and that's where we drew our asymptote. So again, let's try some values, some points, and if you want to pause the video, you can, and see what we have here. So I have 5 and 4 is going to be here. Then I have 6 and 3 is going to be here, so I can kind of see what my shape is, and I know I'm okay, and I know where I'm supposed to be. And then I have 2, 1 is here, 3, 0 is here, so it kind of just lets me know where things are going to go. Let's back that up just a little bit. So I can grab all of my points there that I placed. Okay, and there's your hyperbola. All right, let's take a look. We'll do one more. Okay, so this time we have our asymptotes are going to be x is equal to, y is equal to -4, and x is equal to -1. So we will draw them. Y is equal to -4. So we have it down here. And then x is equal to -1 right here. So again, our domain is x such that x cannot equal -1. Everything else is okay. And our y, our range is going to be f of x such that f of x is not going to equal to -4. Right, again, we'll pick some points so we can graph it and see what the general shape looks like. And again, all these we are graphing, we're graphing reciprocal functions here that look like parabolas. Okay, so I have 2, -5 is going to be here. And then 0, -7 is going to be here. So I know that I'm on this side. And then -2, -1 is here. -4 and -3 is here. So I know I'm going to go this way. And then I'm all set. All right, thanks so much for stopping by today. You have a great day.